Hello, my name is Sasha, I'm 38 years old and I'm from Austria. I'm a technical geek, also I'm totally into 3D printing and 3D scanning. And today I want to show you my current side project. It's this electric Formula 1 car, electric kids car from the 90s. So it's a vintage model built back in the 90s from an Italian company, TT Toys. And why I'm going to scan this 3D, this kids car body is because you don't get any spare parts for it today, except you're going to buy the same model somewhere. And the possibilities I have after 3D scanning this body is to create modifications, to have a backup of the body. If something breaks, I can make a replication of the section, and also to make modifications and create some sturdiness on different sections. Example, the driver's seat, because it has no bracket underneath, that's why it has a dent and I want to fix it the correct way. The 3D scanner I'm going to use today is from Einscan Shining, the Einscan Pro HD. I use it since 2 years and I'm totally happy with it, and also the quality of the scans is exceptional. So really professional tool. Yeah, it has a cost, but it's a working tool for me and it helps me a lot. The most thing I'm into it is the accuracy of the scans, because when I'm going to modify or make some things in CAD with the scanned model or reverse engineering, thanks to the accuracy, I know when I'm going to print out something, it will fit straight on or with less modification, and also reduces the printing prototypes, which I have done in the last years. When I hadn't such a great scanner, I have to create multiple prototypes and approach millimeter by millimeter to the final design. And with 3D scanning in such accuracy offers me better opportunities and straightforward a better workflow. So today I'm going to show you the 3D scan of this body, and also talk about how I'm going to scan the body from the Formula 1 car, and the pros and the cons, what I have to take care of while I'm scanning, and also talk about my setup, my laptop, and what I have also around here to accomplish this 3D scan job, to get as best as possible a 3D body as a 3D file, which I can modify later on in CAD. So now the second part of this 3D scan job I want to talk about. There is some preparation you have to do or to think about when before you start scanning, which means you see your object and then you have to think about, okay, what I have to do or prepare so that the scan went pretty fine. And now I want to talk about my setup, what I have prepared here for this scanning job of the Formula 1 F1 kit car, and to make it a digital copy of it for modifications and repair operations in CAD. See the model? So this is the model, the car itself. So first question maybe that could be occurring for the viewers is, why I have put this one on the turntables and what are these markers for, or those stickers. So this one is my turntable I use normally for 3D scanning. Also with markers, I've made a global marker file, but in this purpose, for this purpose, it's easier for me to go around the model. You have to take care when you choose for scanning big objects. You have to have some space to turn around the model to get good scans, and for this, to overcome this problem, I use this turntable, which will help me in this case. One thing I want to talk about 3D scanning is that sometimes it can happen that surfaces are black. In this case, for example, there are stickers on this car, like this one, and there are black stickers, also those black surfaces on this linkage. And the thing is, when I try now to 3D scan this one, also on the back, there are black sections. Means that the problem is when you are trying to scan those won't be replicated into the 3D model because of the scanning method. It's light-based scanning, and the thing is, to overcome this, you can use scan spray. What also one thing is why I placed the chassis below. So because I just want to have the body and not the wheels or those those metal things, also the rear. I placed it on the chassis because I want the edge to be lifted from the ground, so I can get the scanning of the edge as clear as possible, and I have a cut edge and not combined with the, for example, with the table, which will make me problems to defer it, and I have to cut it away in the 3D model. That's why I'll put it on the chassis. There is no focus on 3D scanning the chassis right now. I just want the body, and it's for me easier to get the edges while it's a little bit lifted. That's why I placed the body on the chassis for this one. And yeah, the 3D scanning, this one will be done with the Shining Scan Pro HD. It's this one. This is my 3D scanner, and there is also the texture color module on this one. I'll just show you the front. On the left side, this is the color module. And this is the software I use, the XCam Pro on my MSI laptop, the GP76 Leopard. It has an RTX 3070, and the laptop was upgraded to 64 gigabytes of DDR RAM to have enough RAM and a good graphics card. And for the scanning operation, I will use the handheld rapid scan mode. For my purpose, this is one of the best currently for this big object. And also it's important, if you are using scan processes or 3D scanning, you will take a look to have your laptop connected to the power with the adapter, because the RTX graphic cards, to give the full performance, you will have to attach it to the power permanently. So this is one thing. So this is my mobile setup. When I have to go somewhere to scan some parts of cars or something, I use this setup, for example. And yeah, here is the preparation for the filming. And now I will start as next to 3D scan this one. The first scan will be without textures, just to show you what happens with the black spots on the car. And if it's possible to scan this one with features. I've also made a pre-check before to see if everything went fine, so I don't need anything special, something that I missed here. So it should go out of the box. And for this scanning process, I choose the handheld rapid scan here on the program, on the laptop. Then I create a new project. I use test. And then I can say if I want to create a texture scan, I have the camera on it, but I don't want to use it now. I use the non-texture scan, and I use the features option, the classic mode, and the resolution 0.5 is totally fine for me. Why I use features? Because the model has a lot of features in it, so I won't use markers or make a hybrid, because if you use hybrid, you have to have markers, and I don't use them now. So I click on apply, the screen opens up, and I turn off the flat detection because I don't need it here. The first thing I push the button on the scanner is it shows me a preview scan process. And in the program on the left side, you have a meter. The meter means you have to take care to stay green, because if you are too close to the 3D model, you will lose the details. You see, it will turn bright. You go through the model and the meter turns red. And if you are too far away, you get into the blue zone, which means you are too far away and you don't get any details. So the most important thing on 3D scanning with the Shining and iScan and XScan Pro software is try to stay as much as possible in green. There is no problem if you just move a little bit into red zone or blue zone, but don't try to be in those zones. You want to be in the green area. Also, if I double click on the play button on the 3D scanner, I can adjust the brightness of the scanning mode, which means if I go too low with the brightness, it won't take a lot of details. If I go too bright, it could interfere with the model, but it also can help out with black spots and black details, like the black stickers on this model here. So choose somewhere in between. There is a recommendation on the homepage that if you have too much red spots, or the model is too much red in the screen and the scan camera you see on the program, you have to lower the brightness. But for this purpose, I will stay in this one, even if it's not recommended, just to show you how the output is. But it means also if you are too bright, you get too much artifacts around, which means I will get some sort of scanning of the table, also of these ones, The axles, which I don't need for this one, is just the plastic body, which I want too. And yeah, let's go for it. I will use the turntable, which should support me in getting around, so I can stay in one position. It's not recommended to stay in one position. You should walk around the model, but the thing is, I don't have the space here. And also take care about your cable, because the cable can twist somewhere, and then when you try to move on with the scanner, you hang, and maybe this also cut the cable. Just take care of your environment. So I choose a position where I can start, and I choose this one, and then I double click, so the message removes from the brightness, and then I click one time play button, and now it starts scanning. The scanning process or the scanning surface turns blue, which means this is the surface I got already, and just take care about the meter on the left side next to the camera window to stay as much as possible in the green. And also take your time while you are scanning. There is no hurry. The more effort you put into this process, the less fails you will have, and also you don't have to reuse some scans. Just take your time and also let the scanner do its job. Don't hurry around the model. It's not about running around the model to get it as fast as possible, because the scanner do already a great job for you. And also don't hesitate to turn around 2 or 3 times the model so you don't miss any spot, because afterwards, when you have done the 3D scan, you will see every spot you've missed. It will be a hole. So also just see how the scanner fills up the holes while you are turning around. It's a combination of moving around, and for me also moving the turntable a little bit to get every spot. And also this process is a little bit time consuming, yeah? And also the afterwork process, but as you can see, just imagine without having a 3D scanner to design such a model. Yeah, if you have learned design or studied design, maybe it's easy for you, but if you didn't have done this before, it will take you effort to get learning and used to design such things in a fast way, and also get used to use the programs. So just the lights are a little bit interfering with me here. And also, while you are scanning, you have to take a view on the screen. What's happening? Where is your scanning spot? So, and also you see where is the missing data. So you can all these spots across. Don't bother about the artifacts I get already inside, like desks or something. Those will be removed in the second step after the scan. Just take care that you get every position, angle, spot of the body, also the edges of the body. Because sometimes you think you have scanned over the section, and afterwards when you are going to generate the point clouds and mesh it, then you will see what you have missed. And then you have to redo or restart the scan. You don't have to start from the very beginning, but yeah, you don't want to mess up with that. It's just take your time, don't rush. The scanner does already a great job for you. It's just this a little bit you have to approach and do, so it gets you a really nice object afterwards. And also keep eye on messages from the XScan Pro software. Sometimes it can say, please, you've lost tracking. If you lost tracking means move to the spot you scanned before, so it will recognize it and go on with scanning. Or if you are too close for a long period, you will get the message you are too close. Or if you are too far for a period, you will get the message you are too far. So just take care about these messages so you have a flawless scanning experience. And also, as I mentioned, take care also about your environment, the brightness also interferes sometimes with scanning. So just nicely turnarounds here. And yeah, the result afterwards you will see is exceptional. That's why I like the shining scanners. I had a few scanners before. Also, I tried with mobile phone scanners, with the apps, with LiDAR, and yeah, you can make your comparison afterwards if they're coming close to it, but you will see the big difference about a mobile phone and a dedicated scanning tool or so, and also the software, because those scan processes are hardware consuming. Also, you can go from the top, so take any direction possible, so you don't miss any spot or hole, maybe, which can happen sometimes, because you are aware, oh, I've got through it, I've seen it, and then when you get the results afterwards, you will see what you missed. So just switch positions while you are scanning, so you are 100% aware that you got everything inside the model you will need. So you see the scanning process itself. If you look at my doing, you see it's really comfortable. It's not that hard to accomplish this one. Yeah. And to redesign this model, you will see the benefit of having a good 3D scanner with accuracy, which delivers high details, will lower the processes, the afterward processes, and also speed up your workflow for whatever you want to do with the model. So, see, should be really good now. Choose this position. This saves a lot of time. The accuracy of this scanner I'm using currently is that good. I've scanned a vase, an antique pottery, and I was able to print it right afterwards without any post-progressing. Just push it into the slicer, place the file to an USB, and go for 3D printing with a resin printer. And the output was also amazing, really amazing. That's what good 3D scanners delivers you, the opportunity. There is also same reverse engineering if it's needed. It depends on your purpose, but if it's needed, you can do it. But there are scenarios where it's not really needed. So it means you can 3D scan the data and put it into the printer, just got the information that a lot of points. So Okay, it looks good till now. Okay, I think I got everything. Let's jump a little bit over here. Okay, now I'm pausing the scan. So the next thing is I have to clean up the model. It got a lot of artifacts from the surroundings, like the tables and so on. And in this software, with the Shift key and the left mouse click, you can mark artifacts you don't need. So in this stage, you've seen, okay, the artifacts are removed. And the next thing is, I don't have the possibility to save now. I can restart the scan, or I can say generate point clouds. And now I want to generate the point clouds as the next step. And then in the next window, I'm being asked, do I choose the quality priority or the speed priority, which means for the model generation of the cloud, and I choose quality priority, it will take a fair amount, and it also informs me that this file or the memory it will use for this operation will take about 12 gigabytes. So you see those scanning processes afterwards are taking a huge amount of disk space, which means take care of to have a clean up disk. And then I say I choose quality priority, and then I choose apply. Now it's generating the point clouds. Don't forget to save your project. First, save your scan. And now I'm going to mesh the model. For meshing the model, I choose unwatertight model because I just need the outer surface. And now this process will take its time. Okay, let's have a look to see it is complete. So there is nothing missing. Just check the edges a bit. That was my most important thing here. Also, it looks pretty nice. So this can, you see, so you can see the model is pretty fine. It looks amazing. The quality looks really amazing. And now, if I want, I can have some cleanup afterwards. And now I have a one-to-one copy from this one. For example, if this wing would break up, I could reconstruct it. And if the other side, I could also, you can use mirror functions, just apply the edit. It looks really, really, really good. Good stuff. For the last part, I want now to have a little talk about the scan job you have seen now. As you have seen, it's quite simple to replicate such physical model into the 3D world or as a 3D file. And that's why I like 3D scanning. The only things what I've already talked about, there are a little bit problems with dark surfaces, deep holes, and there are possibilities and also reverse engineering techniques how to overcome these problems. Also, I have talked today about such markers. These are these ones for the HD, for example, for the 1 scan. There are different sizes, but you cannot use every marker for every scanner. It depends on the scanner you are using. These are the small ones. I think they are 7 millimeters or so in the diameter. And those, for example, helps you when you have a big plane surfaces without any features. Feature on a model means there is some, it's not a plane surface, which means there is a hole, there is some sort of bubbles inside or surface, a stick or something, which is a feature too. And the good thing is about scanners, they could recognize features, and it's about alignment. That's all the thing. While you are scanning, the scanner should know, okay, this is the left side of the object, this is the right side of the object. And if the model has different features, for example, on one side I have a hole, on the other side I don't have one, the scanner and the program knows, okay, this is the left side and this is the right side. If it doesn't have features, for example, if you would scan a hood from a car, a hood, engine hood, the problem is it is a plane surface for a long distance, and you have seen the reflection from the scanner. This is the scan window you have. And in this window, there should be some features inside if you choose feature alignment. And if there is no feature, the scanner doesn't know and the software doesn't know, okay, where I am currently. That's one thing. And how you can overcome this thing, for example, if you have a less feature object to scan, you can use those markers. Those markers helps from the position, from the haze, Also from the scanning process, it's a mask process, it helps the scanner to recognize, okay, yeah, it's a plain surface, I have no features, but I have markers, and the distance to the marker is on this point different than to the next different marker. The only thing you have to take care, there should be at least, I think, 3 or 4 markers inside the window, so the alignment will work. So regarding your scan object, it depends totally what you are trying to accomplish and what is the main goal. So which means if you have a rich feature object, you can try to go without markers, and if it doesn't work correctly, you can add on markers. You can buy them from mostly 3D stores, also from Shining, I think, directly, and that's one big benefit of it. So in that case, markers would help you also having plain surfaces. That's one thing all scanners have, plain surfaces, having features for alignment, and what I like also, the alignment in XScan Pro from Shining works like a charm. So I don't have, when I start scanning, I take my process, I do it gently, I take my time for scanning, and mostly in the first run I'm done with it, and the result is perfect. Sometimes it can happen that I have to redo a scan, but that doesn't mean that the scanner is bad. There are so much impacts and variables that can interfere with your scanning. For example, as I told you, the brightness of the spot you are scanning. For example, if you go outside and scan while the sun is shining and everything is reflecting, every scanner would have problems with that. So in that case, also you have to take care about your environment, where you are scanning. Do you have also the place for scanning? Because as you have seen, I use a turntable, and the thing is, the turntable helps me to overcome the space which I don't have to turn around, also for the recording now, and also take care about the cables, the limitations, because if you have a scanner with a cable, the maximum space you can move around is the cable, for example. And also you have to take care that you have a good sight on the screen of the laptop or the workstation which you are scanning for, because it gives you an idea, okay, where I was already and where I have to go, and also the distance of the scanning, because while you are scanning, I recognize it every time on myself. Sometimes I move too much forward, sometimes I move too far away, and the good thing is that XScan Pro has a meter which indicates, okay, you are in the best spot, the green spot, which gives you the best results of scanning, and afterwards less cleanup of the model. That's one thing. And yeah, I'm really proud to have this scanner in my repertoire as my tool, and you see it does an amazing job for that. So thank you very much that you joined my video. Bye bye.